Hey guys, today we're going to look at lesson 7, which is the last lesson of your unit. We're just sort of like looking at two situations with radicals that are slight applications of radicals. In the first two, you're looking at simplifying expressions that contain fractions and radicals. So your two goals for these are to rationalize the denominator. Remember, you can't have a radical in your denominator. Rationalize denominator. And then the other goal is to get a common denominator so that you can express this as one whole fraction rather than two separate ones. Okay? So what I do first is I rationalize my denominators first. So in the first radical, I have 3 radical 2 over radical 5. Remember, the 3 is multiplying in the numerator because it's really over 1. I'm going to multiply by radical 5 over radical 5 to rationalize that denominator. I end up with 3 radical 10 over 5 minus, and then I'm going to rationalize the radical 1 over radical 3, which is really 1 over radical 3 because the square root of 1 is 1. And I'm going to multiply that by radical 3 over radical 3 to rationalize that denominator, and that's going to give me radical 3 over 3. And now I'm going to try to do the second part, which is get the common denominator. So I am going to make my common denominator 15. I set it up underneath, usually like sort of lined up like that. And I say, okay, well, the first one would have to be multiplied by 3 over 3. So my numerator becomes 9 radical 10. And the second one would have to be multiplied by 5 over 5. And that would be 5 radical 3 over 15, because the 5 is rational. And now I express this as one big fraction. This is 9 radical 10 minus 5 radical 3 all over 15. And I look to see if I could simplify in any way. I can't. This would be my final answer, and that's because when I look at this, I don't have any common factors among the 9 and the 5 and the 15. Like 3 doesn't go into all of them, 5 doesn't go into all of them, and so therefore that was my final answer, 9 radical 10 minus 5 radical 3 over 15. Okay, so do one more like that. Example 2. I'm going to first, I only have one irrational denominator to rationalize, so I'll take radical 2 over radical 5, and I'm going to multiply by radical 5 over radical 5, and that's going to give me radical 10 over 5. Minus, and square root of 6 is really over 1. So now I need to get my common denominator, which will be 5. So the first fraction stays the same. The second one I have to multiply by 5 over 5. So I have 5 radical 6 minus 5. So I put this all into one fraction. Radical 10 minus 5 radical 6 all over 5. And I look to see if I could simplify. I cannot, because for the same reason as before, that if I look at all the rational numbers, right, 5 and 5 have a common factor, but not with 1 also. So it has to have a common factor with all of the rational parts. And then the last little thing is you guys have never seen equations that contain radicals. So going down to example 3, I'm just going to do one of those because they're really simple and straightforward. And you're solving equations, which means you're trying to get x by itself. So your goal is to try to isolate x. And so you're just going to move terms over. Like I would first add 4 radical 3, just if it was like just a regular number. And I have 3x radical 2 equals 12 plus 4 radical 3 because they're unlike terms. And I want to isolate the x, so I can divide by 3 radical 2. It's just like if it was like AXB, I could divide by AB. And divide by 3 radical 2 because they're all multiplying together. So divide by 3 radical 2. And you end up with x equals 12 plus 4 radical 3 over 3 radical 2. However, you have to remember, I can't leave an irrational number in the denominator. I have to rationalize this. So I'm going to multiply by radical 2 over radical 2. And then that's going to end up giving me, in my numerator, I'm going to distribute. So I'll have 12 radical 2 plus 4 radical 6 all over 3 times 2, which is 6. And then I look to see if I can simplify, and in this one I definitely can. I have 6, 4, and 12 that all have a common factor of 2. So this becomes 3, this becomes 2, this becomes 6. And I just also make sure that my radicals don't contain any perfect squares that could maybe be simplified. They're fine. So my final answer here is 6 radical 2 plus 2 radical 6 all over 3. Okay? So you're just going to do some of these tonight. This is your last lesson of the unit. And then we'll move on tomorrow to something different. All right. Thanks, guys. Bye.